Hi there, it's Katie here talking. And in this video, we will be looking at what I mean by a complex system and how it applies to making healthy choices for your own human body. Now, before we begin, understand that this video is made for those of you who are interested in diving deeper into the technical concepts involved in this month's theme. My goal is to keep this video at a technical level that I think most of you could be able to take in. Now, that being said, this doesn't mean that we all need to take it all in or that we are all in a space where it is useful to take it in. My recommendation is that if you are excited and want to know more about this topic, then give it a listen. If you find that it isn't resonating or stressing you out in any way, then please don't worry about it. Maybe return to the higher level presentation of this material, that which was released earlier this month, and to really focus on the practices, understanding the level of concepts that are useful to you. Then, if you ever feel called to return to this video, then perhaps that would be a better time for this material to serve you. All right, now that we're clear on that, shall we jump in? To make sure we are all on the same page, let's get started with what exactly I mean by a system and how it relates to making healthy choices. A system begins with a set of factors, here modeled by some random shapes. We define any system by clearly defining a set of boundaries. So here, a triangle, hexagon, and circle are inside the system. The heart is outside of the system of interest. Now, this is totally abstract, so let's make it more relevant to our area of interest. We could define a system as a set of different foods in a bowl. Here, a salad. Or maybe the system of interest is just one food, a tomato, because maybe we want to study and understand the different factors that make up a food. The different polyphenols, the macronutrients, the fiber, or anything else that is part of this one food. Of course, a system could also be the human body. Now, this is the system of primary interest for us in this program because we want to understand ourselves as the whole system, the whole human body that we are. While studying the human body, we can examine subsystems, those made up of biomolecules, cells, tissues, and organs. For example, we could address one specific system that is an organ, such as the heart or liver. Or maybe we are looking at a subsystem that involves multiple organs, biomolecules, and other biological factors, such as the cardiovascular system. Get the idea? When I speak to a system or a subsystem, I just mean a set of factors that we have defined as within our area of study. These factors are connected via mechanisms and pathways and generally perform certain functions. To add to our understanding of a single system, we now need to understand how systems interact. Here, I've shown how we can examine the interaction between a salad and the human body, something that you yourself have likely considered. As we consider this interaction, we want to stay focused on the specific outcome of interest. Here, our outcomes are generally going to be health related. For example, how does eating a salad make an individual feel? How does eating a salad impact an individual's body mass? Of course, there are many different questions we could ask and many different ways to look at this. Along the way, we'll also want to examine specific subsystems. For example, how does eating salad impact blood markers of inflammation? Or how does eating a salad impact a blood lipid panel? So, to wrap up what I mean by a system, and to apply this to our work here with the Reprogram systems approach, here I have modeled for you the general pathway for the reprogram systems models. Here, we see how a specific input, something that is usually linked to behavior, impacts a particular system and leads to a particular outcome of interest. I'll speak more about this shortly, but first, let's address a second important concept. What is a complex system? Let's begin with what a complex system is not. A complex system is not a simple system. So, in a simple system, we have a small number of variables interacting, forming clear pathways. And in a simple system, it is easy to understand how a change in an input variable causes a direct change in an output variable. Here we see a diagram of a simple system. The first piece is that input variable, impacting a specific factor within the system. What we are generally interested in is understanding a specific outcome, which we can do by tracing what happens when you make a change in the input variable. That change in the input variable causes a change in the internal factor, which causes a specific outcome. So, with this clear pathway through a simple system, we can clearly understand all that is at play. We can understand all that would happen through the entire system if we made a change in that input variable. And we could easily gather data to enable us to predict how a change in that input variable would cause a change in the internal factor and create specific outcomes. Let's take a look at a couple examples that we are all familiar with. Say you walk into a dark room and you want to be able to see. So you flip a switch, which directly causes a change in a circuit, causing the light to turn on. Here we see how a change in an input, flipping the switch, causes the desired outcome, the light turning on. Most importantly, it is quick and easy for me to explain the entire pathway to you and for you to understand how the pathway unfolds mechanistically. As a second example, say you have lunch with another individual who has a runny nose and coughs every couple minutes. The next day, you wake up with a sore throat and some sniffles. What just happened? Well, you probably already understand that the interaction with an individual led to the transfer of a virus causing an infection in your own body. Once again, the point is that we have a clear and simple pathway that we can fully comprehend. Now, let's think about an important topic that you are probably here to better understand. Let's think about food and consider how making a dietary change may impact the health of our own bodies. Rice. It is made up of different things: macronutrients, primarily starch and also some protein. It is also made up of different micronutrients. So we can ask a question: would it be a healthy choice to eat more or less rice? Now, to answer that question, we would first need to think about what part of the food to consider. Let's just think about the large amount of starch in rice. Is it healthy to eat rice given that it has a bunch of starch? To begin to answer that, we would need to think about the impact on the individual's body. Starch is a rich source of glucose, so it would provide the body with a bunch of glucose, which is a certain form of energy. So, is that healthy? Well, to address that question, we'd need to talk about the energetic state of that individual. I would want to pull in a discussion of insulin sensitivity, a rabbit hole that we'll save for another time. Instead of going down any rabbit hole, I ask that you recognize the plain fact that when discussing food, it is not reasonable to think about a single input variable impacting a single internal factor. Rice, a whole food, is itself made up of a whole bunch of different factors. And all these different factors are going to enter the human body and interact with all of the internal factors supporting the human body, which are too many to count. Okay, let's take a second example. Maybe we are considering whether to eat more or less beef. We want to know, is beef healthy? Well, to answer that, we'd want to discuss what makes up that beef, the different types of proteins and fats, along with the micronutrients and other factors contained within it. Then we'd want to consider what we mean by healthy. What specific health outcomes are we speaking to? This will guide us to understand what bodily systems we are interested in. Maybe we are interested in the vascular system. Maybe liver health? A little hint. We'd have to consider both as they are intricately connected. Once we understand that, we need to begin discussing lipoproteins and cholesterol, along with triglycerides and other internal factors. From here, we need to begin connecting the dots between all these different internal factors and all the different factors that make up beef. Of course, as we do, we'd want to know more details about the beef. Are we talking about a ribeye from a cow raised on pasture, or are we talking about a Big Mac? Do you see what I'm getting at here? Here, what I'm getting at is a particular problem I see splattered everywhere in the health sphere, whether that's in marketed diets, supplements, exercise plans, or whatever health-based information you may be receiving. The problem is that the human body is not a simple system. Even more, food is not a single factor. It itself can be considered a complex system made up of countless factors that we can only begin to piece apart to study and comprehend. So, when we talk about a specific diet, keto, for example, what are we really talking about? Are we talking about whether we should eat more beef? And if so, what kind of beef? Are we talking about avocados and their impact on the human body? Or are we talking about the systemic impact of the diet as a whole? For example, the impact on insulin or inflammatory markers when you significantly lower the carbohydrate in the entire diet. Once again, a little hint here, we would want to talk about all of it because it all matters. Now, I don't want to just pick on one diet because this pertains to all diets. Are you considering whether being a vegan would be healthy? Again, we have to acknowledge that this is a highly complex question involving many different complex systems. Here, we arrive at a sort of foundational problem underlying the process that is learning to make healthier decisions. When questioning diet or other lifestyle behaviors, there are many factors at play. How many? Well, there are more factors at play than us mere humans can understand all at once, which means that it is impossible to try to understand healthy behavior using this simple reductionist lens. I mean this quite literally. By definition, it is impossible to fully understand a complex system by breaking it apart into individual pieces. I'll get to more about this in a moment. For now, what I want to say is that, unfortunately, this is what our modern world tends to do when it comes to understanding health. We are marketed specific foods or diets because of one particular nutrient. Drink more red wine because resveratrol is good for you. Eat low carb because carbs raise insulin. Eat a vegan diet because animal protein promotes cancer growth. The idea? Take any single food or any particular diet, and there will be a list of pros and cons based on any particular nutrient. Because of this, we end up in this horrible cycle that is trying to figure out what to eat while being overwhelmed by information and unable to see a clear signal that tells us what is truly healthy. Let's fix this by, well, changing up the model. Okay, now that we have some solid background information, let's finally clearly address the question. What is a complex system? In a complex system, a large number of variables interact, forming indistinguishable pathways. It is important to understand how a change in input variables cause a direct change in all other variables. The human body is made up of countless complex systems, made up of networks of biomolecules, cells, tissues, and organs. In a complex system, we have this key point. The whole is greater than the sum of its parts. So here, looking at this system, you could theoretically work to break the system down into individual pathways and mechanisms in an attempt to understand the pieces. Then you could piece the system back together to form a coherent whole. However, there are two problems with this when it comes to our situation at hand. One, you are a busy individual with so much else to do in your life. So the idea that I should start telling you to get to work and learn all of the pathways and mechanisms that play in every sort of potential health problem and then combine them all into a coherent whole, well, that is completely unreasonable. Two, even if you were completely motivated, you would still have a problem because of this point. In a complex system, the whole, that is, the outcomes created by the whole system, are greater than that which would be created by combining the outcomes of the individual components. In other words, if we want to understand specific health outcomes, we have to keep the whole intact. Okay, let's break this concept down. And yes, I do see the irony in that line, but getting past that. Here, we see a slightly different model of a complex system. But what exactly do I mean by a complex system? In a complex system, what we have is a larger number of variables. Maybe that's 5, as shown here, or maybe it's 1,000,000, or anywhere above or in between. Here, let's not get too overwhelmed and keep the model with a reasonable number of factors. What we see is 5 different factors within a system, and these factors interact via many different mechanisms. We see A impacting D, which impacts B, then E, then C, which feeds back onto D, which is also impacting A. Given all these interactions, how could we trace a pathway from one variable at the beginning all the way to its impact on a factor downstream? What we cannot do is piece apart this whole system into individual mechanisms. And what we can't do is understand each individual factor's role in the pathway. What we can do is recognize the input variable of interest and to study what a change in that variable would do to a specific factor of interest downstream, what I would call the output variable. As we do this, we don't want to get bogged down in all the individual mechanisms along the way. So as we do this, there is a need to step outside of the complexity within the system. So here we have our solution to what to do with complex problems. Given that your body is a complex system, there is a need to take a step outward. From a broader perspective, we no longer get mixed up in the intricate and interweaving pathways within. From this broader perspective, we can see how our behaviors impact the body's most important systems. Now, that was a whole bunch of technical jargon. So let's take it back to earth, to our real lived experience. What we want to do is learn to make healthier decisions, which means we want to understand how specific behaviors impact the system of interest. Maybe that has to do with how you feel as a whole human being. Maybe that has to do with a set of factors within the cardiovascular system that we can use to predict disease progression. While doing so, we want to consider how this is in relation to our behavioral choices, what we eat, how we move, and other lifestyle patterns. The point is, we want to begin making healthier choices from this zoomed out perspective, getting ourselves away from those nitty-gritty details, all those mechanisms and pathways that get us bogged down and overwhelmed. We want to begin making healthier choices looking broadly at the most important systems defining our states of health. Now, as I say this, you may be imagining a sort of problem that arises. What defines the body's most important systems, you may ask? In addition, what happens when there is a need to understand specific pathways because of specific problems that may be arising? What if you are interested in specific pathways within the cardiovascular system because you want to reduce your risk of cardiovascular disease? Or what if you are interested in fluctuations in blood pressure or blood sugar and how that contributes to the progression of diabetes? Now, this is all to say, how can we address specific problems if we want to stay in this zoomed out perspective? I am so glad you asked, because these are such important points. While I believe that it is important that we can approach health conscious decisions from this zoomed out perspective, wherein we are taking the entire system as a whole system into account in all of the complexity that cannot be broken down. Now, while we are doing this, we can also get to work understanding specific subsystems and the relevant pathways involved in health and disease. In doing this, what we are doing is ultimately balancing this zoomed out or holistic perspective while also being informed of more precise pathways that may be involved in specific cases. Balancing these different perspectives as we understand our health challenges through various systems. That's the big idea here. So, for example, we can look at important subsystems supporting the body, perhaps through a system-wide lens that is the circulatory system. While looking at this model, we could examine different mechanisms and pathways at play underlying different aspects of one's health, such as energy levels, something that is relevant to the day-to-day, along with pathways of insulin resistance and metabolic health, something that is highly relevant to modern disease progression. We could also examine energy balance and regulation across different subsystems, including different tissues and organs. We can examine these all as separate systems and then pull them back together to form a more holistic view. That is all the sorts of things that we will be working through as we continue to examine the body as a complex biological system. And as we do, we will continuously educate ourselves on what it means to make healthier decisions for our own bodies. That's all what we're going to continue to do here. Thanks so much for listening.